Hello, grade 12. In this video, I am going to show you the methods of adding vectors. In our modules, there are two main methods of adding vectors that I have mentioned. Number one, the head-tail method or polygon method, otherwise known as graphical method, and the second one are the analytical methods of adding vectors. Let's have head-tail method first. Also known as graphical method or polygon method is the head-to-tail arrangement of vector arrows representing a set of vectors. This method requires some knowledge in scaling and the use of ruler and protractor. The ruler measures the magnitude and the protractor measures the direction of our resultant vector. The scaling process helps you in cases where big magnitudes have to be reduced to smaller units. An example is shown on screen. Again, head-tail method in finding the sum of vectors only requires ruler and protractor. We will not employ any mathematical procedures or even use your calculators to determine our resultant vector. Let's try sample problem number 1. Gino walks 600 meters east, then turns 400 meters north, and finally walks 300 meters west. Determine the resultant displacement of Gino. Before doing any calculations or solving any problem in this particular topic, always begin by identifying what are given and required in the problem. So, if you have noticed, our displacements are denoted by letter D with an arrow on top to denote that these are vector quantities. Shall we say we used the scale of 1 centimeter equals 1 meter. Considering our cardinal directions, we are going to draw or set the directions to be followed in doing graphical method of our vectors. So this will be our guide, the northern direction, southern direction, eastern direction, and western direction. So let's draw our first arrow. If this is 600 meters divided by 100, that means on your graphing paper, the length of our first arrow is 6 centimeters. And this green arrow is displacement 1 of 600 meters due east. Next, placing a guide or direction guide at the tip of our first arrow, we will draw our second arrow. So this is 400 meters due north. On your graphing paper, 400 meters due north will have a length of 4 centimeters. And then, at the tip of our second arrow, draw another direction guide, then draw the third arrow of 300 meters west or 3 centimeters west. Now, our resultant displacement is denoted by this broken arrow colored red. Using nothing but your rulers and protractor, you will be able to determine the direction of our resultant displacement, which forms 50 degrees north of east, to be 500 meters, 53 degrees north of east. So if you are going to do this process on your graphing paper, if you were very accurate on your measurements on these arrows, you will be or you will arrive at the same answer as I have on screen. So don't use any other tools or devices, just use your arrow or just use your ruler and protractor and you will arrive with these results. Let's now have method number 2, the analytical methods. Generally, analytical methods look at whether vectors are lying on the same axis of the Cartesian plane, such as the x-axis or y-axis. Do they form a 90-degree angle with each other, or on how many vectors are involved? For any specific case, the following methods are applied to get the sum of vectors. So these are the diagrams that I have shown in the module. So we will be going over each of these examples in a while. So analytical method number 1, adding vectors in the same or opposite direction. If the given vectors are lying on the same axis of the Cartesian plane, their magnitudes may simply be added or subtracted depending on their direction. Let's have example problem number 2. A sailboat traveling at 20 meters per second due east is being driven by the wind blowing at 40 meters per second due east. Find the resultant velocity of the sailboat. Shall we say we use the scale 1 centimeter equals 10 meters per second. Let's identify what are given in the problem. So this time we have velocity. So we use the symbol V with an arrow on top to denote velocity as a vector quantity. So how do we represent these velocities using arrows or using our vector arrows? So first and foremost, draw your direction guide for northern direction, southern direction, eastern and western direction. So our first arrow is directed due east. On your graphing paper, this would measure 2 centimeters. So this is velocity number 1 of 20 meters per second due east, and a second arrow will be connected at the tip of our first arrow. But first, let's put another direction guide at the tip of our first arrow. Then draw a 4 centimeter long arrow for velocity of 40 meters per second due east. Now, our resultant velocity is simply denoted by this red broken arrow. And the length of this arrow would be 60 meters per second due east, or simply 6 centimeters long on your graphing paper. So how did we arrive at 60 meters per second due east as our resultant velocity? Let's have a look at the following processes. Since the vectors are on the same axis of the plane, they can be added as follows. Solution: resultant velocity equals v sub 1 plus v sub 2. So our first velocity is positive 20 meters per second, since all directions pointed to the positive x-axis will take positive sign. So we have 20 meters per second and another positive 40 meters per second. So since they are pointing to the same direction, we may simply add their magnitudes as follows and follow the direction of these two vectors, which will give us resultant velocity of 60 meters per second due east. Let's have another example. Example number 3. A delivery truck went 15 kilometers north, then 28 kilometers south. Find the resultant displacement of the delivery truck. What is the total distance traveled by the truck? Shall we say we used a scale of 1 centimeter equals 5 kilometers. So given in the problem are two displacements. Denote them with an arrow on top. Required are as follows. A, resultant displacement of the delivery truck, and B, total distance traveled by the truck. We have to take note that displacement is a vector quantity while distance is a scalar quantity. So first, let us draw our cardinal directions for the northern, southern, eastern, and western direction. Let's draw our first arrow. That would be 15 kilometers north or 3 centimeters using your ruler pointing northward. Draw a direction guide at the tip and then connect our second arrow. Just to show distinction, I somehow moved towards the side our second arrow for 28 kilometers south, or this would be 4 point. Okay, so again, we have our first arrow, 3 centimeters north, and then our second arrow would be 5.6 centimeters going downwards, considering 28 kilometers divided by 5 is 5.6 centimeters using your ruler. So this will be our displacement number 2 directed southwards. Therefore, our resultant displacement will be drawn from the origin or the tail of our first vector, first displacement, to the tip of the last displacement, which means this would only be 13 kilometers south. So here are the processes to be used in solving for our required quantities. So for letter A, resultant displacements, Since the vectors are on the same axis of the plane, they can be added as follows. Resultant displacement equals the sum of our first displacement, the magnitude of our first displacement, plus the magnitude of our second displacement. So that would be going north, positive y-axis is positive 15 kilometers plus 28 kilometers going southwards, which will take a negative sign. So that would be 15 kilometers minus 28 kilometers. Therefore, our resultant displacement would be negative 13 kilometers. We may remove this negative sign by giving it an interpretation that the delivery truck went 13 kilometers south as its resultant displacement. For letter B, we are asked to find the total distance traveled by the truck. The total distance is given by d sub t equals d sub 1 plus d sub 2. All we have to do is simply get the sum of the magnitudes of our displacement without considering our direction. So the total displacement, or total distance rather, is the sum of the path traveled by a body from the starting point to the end point of its destination. So we are simply adding up the length of the paths traveled by our delivery truck, which means 15 kilometers plus 28 kilometers will give us 43 kilometers. Okay, another analytical method of finding the sum of vectors is adding vectors at right angle with each other. So in mathematics, we use the Pythagorean theorem to find for the unknown sides of a right triangle. And we will be doing the same in this method. So the Pythagorean theorem may be used to find the resultant vector given two vectors which are perpendicular to each other or forms 90-degree angle with each other, and the functions of the acute angles of a right triangle summarized as SOHCAHTOA for sine of angle theta is equal to opposite side over the hypotenuse. Cosine of angle theta equals adjacent side divided by the hypotenuse, and tangent of angle theta, which is equal to opposite side all over the adjacent side. Let's now have sample problem number 4. Two porters are pulling a crate with the force of 20 newtons due west and 30 newtons due south. What is the resultant force on the crate? So we are now talking about forces. So we use the symbol F with arrow on top. Required is the resultant force. Shall we say we use the scale for every 1 centimeter is equivalent to 10 newtons. Now let's draw our cardinal directions: northern, southern, east, and western direction. So our first arrow using this scale will be 2 centimeters in length due west as pointed by our green arrow. That's 20 newtons due west. Next, we will draw our direction guide at the tip of our first arrow, then draw our second vector arrow. That's 30 newtons south, or on your graphing paper, this would be 3 centimeters pointing south. So this is our second force of 30 newtons south. Now, our resultant force is denoted by this red broken arrow. And the direction, based on this orientation, okay, and its length will be given by the following procedures. So we have to take note that force 1 and force 2 forms a 90-degree angle with each other. Therefore, to find for our resultant force, we may simply use the Pythagorean theorem. So if this is side A, this is side B, this would be the hypotenuse. So the hypotenuse F sub r will be equal to the square root of F sub 1 squared plus F sub 2 squared. Okay, substitute the values. That's the square root of, with the western direction, F1 takes a negative sign. That's negative 20 newtons squared plus negative 30 newtons quantity squared. Okay, performing the necessary mathematical calculations. Okay, your calculator would read resultant force is equal to 36.06 newtons. To find for the direction of our resultant force, we use the formula angle theta is equal to arc tangent of opposite side, or the magnitude of F sub 2 divided by the adjacent side of angle theta, which is F sub 1. Substituting the values, we will have arc tangent of negative 30 divided by negative 20 newtons. The result would be angle theta is equal to 56.31 degrees. Therefore, to summarize our results, resultant force is equal to 36.06 newtons, 56.31 degrees south of west. So this angle measures 56.31 degrees south of west, and the length of this arrow is 36.06 newtons. Or in total, our resultant force, or the resultant force on the crate, is 36.06 newtons, directed 56.31 degrees south of west.